Yes, please.
Okay, thank you. Good morning, everyone. Welcome to our Indonesia Vlab Center of Excellence Regional Focus Group Discussion 2024 and also BMKG Online Discussion 222. The Honorable, the Head of Education and Training Center of BMKG, Dr. Nelly Floridariama, the Honorable to all speakers in this meeting and to all participants and other colleagues. Here I'm Richard and I will be the moderator of this meeting. Today, we are very happy since we have experts from BOM and NOAA join us in our regional focus group discussion. Also together with the expert of BMKG to share their knowledge and experience on flood analysis using satellite data. But before that, I would like to invite our Head of Center for Education and Training, Dr. Nelly Floridariama, to give a short remarks to our regional focus group discussion. To Dr. Nelly, time is yours, please.
Thank you, Richard. Good morning, good afternoon, and good evening for all of you. I would like to welcome everyone to our fourth regional focus group meeting, which also serve as our 222nd online group discussion of BMKG, hosted by the Indonesian Vlab Center of Excellence. Today, we are very honored to have expert from the Bureau of Meteorology, Mr. Bodo, and also from NOAA, Mr. William Straka, who will join our expert from BMKG, Rion Soeb Salman and Idan Abu Bakar to discuss about the utilization of satellite meteorology for flood analysis. I also see many experts, colleagues from all over the world, if I may say so. Joining our discussion today. And as we all know, floods are among the most devastating natural disasters affecting millions of lives and causing significant economic damage. By leveraging satellite meteorology, we can enhance our ability to predict, analyze, and respond to flood events. So that is why today's topic is so important, as it helps us prepare and provide our best service to our communities. This meeting also serves as a platform for us to share our knowledge and experience. So I encourage all of you to actively engage in the discussion, share your insight, and collaborate towards our common goal of improving flood analysis and management through satellite meteorology in our countries. To conclude, I would like to thank you and appreciate everyone for being here. Let's make this meeting productive and impactful. Thank you very much.
Thank you very much for the opening remark of this meeting today, Dr. Nelly. Well, before we start the meeting today, I would like to introduce you the presenter of this discussion. We have several presentations today. First is from Mr. Rion Soeb Salman from BMKG Maluku and Mr. William Straka for NOAA and Mr. Idan Abu Bakar from Public Weather Center BMKG and Mr. Bodo Seske from BOM Australia. Before the presentation begin, let me inform you all. If you want to asking some question, please type in the chat box during the presentation or raise your hand in discussion session. We will have a discussion session after all the presentation is done. And for the presenter, because of the limited time, your presentation is around 10 minutes. And well, we will start for the first presentation by Mr. Rion Soeb Salman from BMKG Maluku and Mr. William Straka from NOAA. Mr. Rion and Mr. William will be present about utilization of existing flood product generation tools of the NOAA Global Flood Product. To Mr. Rion and Mr. William, the time is yours, please.
Thank you, Richard and Ms. Nelly. Thank you very much, all colleagues from all the world, and Mr. Bodo, Idan. I see from KMA, Jinho. How are you? And also, I will give the brief introduction before William take a lead to give the overview about the flood products, and I will take the lead again about the utilization of the flood product from Noah. Okay, so I want to share my screen first. Wait a minute. Okay. Okay. Richard, can you see my presentation?
Yes, we can see. Very nice.
Okay, good. So sorry. Okay. In this presentation, William will take a lead about the introduction or overview about the flood products data, and I will take a lead for the how to download and display the flood product data. So, William, are you there? And you can start the presentation, bro.
Yeah, I'm here. So, welcome. I am actually in Oshkosh, Wisconsin tonight at the Experimental Aircraft Association Air Venture uh, Air Show. It's a great outreach to pilots and other users. So, slightly different location than about a 2-hour different location than where I normally am in Madison. So, I'm going to give a brief overview of the operational VIIRS flood products and the AHI flood products, which are being operationalized by the Australian Bureau of Meteorology. These products can provide a flood aerial extent that can use for situational awareness. On a daily basis, the combined product with the VIIRS high resolution data and the higher temporal AHI data provides the best coverage in regions that are covered by the AHI in the Asia-Oceania region. Under clear sky conditions, obviously the VIIRS gives us the highest resolution because it's polar orbiting, and so it's always recommended to use the VIIRS product when it's available. But when it's not, when you get clouds that are passing through, that's why we have the AHI and other geostationary flood maps, which basically composite out the clouds, and then you get the maximal flood extent during the daytime hours. The resolution, again, as I mentioned, for VIIRS is about 375 meters. For ABI, it's about 1 kilometer nadir. So we can go to the next slide. So again, the process for both the geostationary AHI products and the polar products are basically the same process. They use the visible and shortwave infrared bands, as well as the thermal bands for inputs. There's a series of decision trees, which then classifies the pixel of one of several different values, whether it's snow, ice, flooded, no flooded, cloudy, cloud shadow, and the like. We'll mention it says we're going to mention in the next presentation. I think it's more, we're actually looking forward to hopefully having another training like we did in 2023 in the coming year, and which will provide a lot more detailed information. Of course, there's detailed information available online as well. So if you go to the next slide. So the actual output from the VIIRS product, operational output, is a netcdf file. That's due to requirements at NOAA to have the outputs being in the netcdf files. However, we recognize that there is a need for these files to be in GIS style files. So we actually do distribute the data in both GeoChif and shape files, and those are be done by just simply taking a Python code that just converts the netcdf file into the shape file or the GeoChif file. The data is available available on the web. It's available if you have a direct broadcast antenna through the CSBP Geo software for the VIIRS products. They can be processed directly at the direct broadcast sites. And also, it's available by WMS services and also on the NOAA AWS system as well. You can continue next. This is just a list of the the products, their availability, and their latency. One thing to note is that there's an asterisk on this product latency for the near real-time flooded products. If you happen to have a direct broadcast antenna, your latency actually is less than 30 minutes. So operationally, though, it's roughly 30 hours from after pass. And again, you can kind of see that each of the daily products are available once a day. The Himawari products are done every hour, composited every hour. So those are available every hour, and then you combine them into a final daily product. Next. So this is just a overview of the flood products. Essentially, we filter out the cloud. We have each granule. We calculate the flood, calculate the cloud, calculate the cloud shadow, and we use the filter to filter out those clouds through a maximal water fraction compositing process, and that derives the maximal flood extent during a flood event, from the near real time, the granule level data. We produce these data sets routinely globally for a 1-day composite as well as a 5-day composite for the flood product. And just for processing speed, we divide the data into 136 areas of interest. It just makes it a lot faster computationally wise to do that. Dividing it even further just makes it, there's no gain in dividing it into further smaller regions. So 136 is about the best computationally wise. Can you go to the next slide? Similar to the daily composite with the VIIRS product, AHI is very similar, or the AHI product is very similar. Again, it's a rolling composite. You're filtering out the clouds as you go throughout the day. We currently are getting the data from the Himawari cloud from JMA, which we greatly appreciate. I know that the Australian Bureau of Meteorology, once they get things operationalized, will also be utilizing the Himawari cloud to download that data and then process it as soon as it's available.
William,
You go to the next one. Yep.
the time is still 2 minutes. Thank you.
Okay, keep going. Yeah. Okay, again, we combine the data into a joint product. Again, very similar. We take clear areas, cloudy areas, and if there's a clear area, we overlay that from the ABI product. Next one. Just briefly, we do correct for terrain shadows and cloud shadows. So I'm not going to go into much detail there, but there is a process to correct to account for those. Next. We determine it as a water fraction. It's better than it's more accurate to do that rather than a water no cloud, no water mask. And we attribute it over a variety of land types. There's some information on how to do this in the references there. You can go to the next one. This is just an example from California, from the flooding from last year. If you can go to the next slide. There are some issues which you can see there. These have been more described or can go more into depth during the actual training that we've had back in 2023 and hopefully early 2025. But again, you can kind of see we take into account some of these things as we go along. Next. This is just an example of the PNGs and the geotiffs. You can go to the next slide. That's combining them all in the ArcGIS, so we can just sort of continue on here. We have a lot of international users, including BMKG and a lot of others. There's some that aren't mentioned there just because we don't have the space there. But again, a lot of these are active users of the products and give us great feedback. Next one. This is just a quick example of how they can be used during the day. Again, I won't go into too much detail, but again, there are methodologies of providing, using the data, the ABI data early in the morning until you have the VIIRS data. You use the VIIRS data when it's available, and then you take that daily composite as the as the final day. So next one. We have a couple of example cases that I know Rian will start working through here in a little bit. This is just a case in 2023 of an international charter event where there was flooding in Vietnam. You can go to the next one. You can actually combine this data with socioeconomic data. It gives you actual population impacts. And this is what's been done by international cases. Next one.
Hey, William, can you in the conclusion?
I just have just a couple of example cases that we operational cases. If you can go to the next one. I think the final point I want to make here is that we do have an archive of data that can be used to assess flood risk, and that's freely available through AWS. It covers from 2012 to 2020 and from August 2023 onward. We're working to fill that gap. If you go to the next one. I think that then goes into this now into Rian's talk here. Sorry about the little overage there. So Rian, go ahead.
Okay, thank you, William. I will. We have a little bit time for some of the presentation, but for the data, we have a real life website. You can see. I will copy and paste to the chat, and we can download the data. So, like William mentioned before, we have GIS data, so you can combine and produce and validate the data with your data. So this data is very useful for the in situ data. So you can combine with impact-based forecast or something data that include in the GIS format. And for this, we have also the NOAA global product for flood product that is FTP link and GPSS. So you can combine it, and we have 136 area of interest. So you can download based on your area of interest. And data format, we have a save file data, and that is can open in ArcGIS, or you can use the Python, and also data from JPS because it blend data from the 5 days before, so you can combine it all to get the fraction data or likelihood data for the flood. And how to display the data, we're using the ArcGIS or many tools in ArcGIS. And you know about that, if you have a capability to use the or manipulate the data in the Python or something program language, you can use that because based on data in NetGDF, and you can also convert to the save file. And is the connect to the utilization, impact response, and weather forecast. So according to the climate change, we have to get the solution. So the impact-based forecast combined with flood product data, can we get the early warning and impact analysis? So that is very important for us. As we know, in Indonesia, we develop the strengthening tool, so that is can use the web-based map that can service us to provide the data directly to each station in Indonesia. And this is the local agreement with the local stakeholder I made with the WRN and William in Ambon City to provide the local point area or polygon as a result direct from the stakeholders. So they experience, they calculate this, we can verify it. And this is the going to the next meeting. And if you have ArcGIS, you can display the data and you can get the actual danger area. You can get the save file, or you can get the annual data or monthly data, and you can combine with the in situ data. So that is the last flood product training from Indonesia, from Philippines. I made with my colleague from Region Training Center in Indonesia. I will share with you all about this study case. Maybe you can combine with your experience with your area. And this is because early warning. So I think the flood product combined with the another data can we make sure that working together about the impact and response. So it's not about the forecast, but about the people impacted by the flood, landslide. So yeah, that is the solution. That is our presentation. Thank you very much. Give to you again, Mr. Richard. Thank you.
Okay, thank you very much, Mr. Rion and Mr. William. And we will move to the next presenter is from Mr. Idan Abu Bakar from Public Weather Center of BMKG. Mr. Idan will be present about early warning and analysis of flash flood event caused by cold lava, case study of eruption of Mount Merapi in May 2024. I remember you that the time is only 10 minutes. Mr. Idan, please, time is yours.
Okay, thank you, Richard. Can you hear my voice clearly?
Yes, very clear.
Okay, thank you. Then let me share my screen. Um, okay, thank you, Richard and good Nelly. Good morning, good day, good afternoon, good evening, everyone. I hope you all are doing well. So before I start, I'll be introducing myself first. My name is Idan Obakar. I currently work at BMKG as a forecaster. And for this time, I will present my presentation with the title Early Weather Warning and Analysis of a Flash Flood Event caused by cold lava, case study of the eruption of Mount Merapi in the West Sumatra on May 2024. So, as we all know, Indonesia is part of the Ring of Fire, which is a region where tectonic plates meet, resulting in the earthquakes and volcanic eruptions. According to Volcanology and Geological Hazard Mitigation Center, there are 127 active volcanoes in Indonesia. And for this time, in line with our theme today, the utilization of satellite data for flood analysis, then I will discuss a case of flash flood caused by cold lava. So based on information from BNPB or the National Disaster Management Agency of Indonesia, and also from the national media, landslide and flash flood have been reported in the West Sumatra around the hills of Mount Merapi, and it recorded more than 60 people died, 10 missing, and the damage has reached over 100 billion rupiahs. This is from the stream analysis. So a few days before the event, we already detected the circulation in the waters western part of Aceh, and which is resulting formation of convergence zone in the central to the northern part of Sumatra. And also, if we look the atmospheric wave, uh, from the atmospheric wave and OLR or going long wave radiations analysis on 10 to 11 May 2024. This is from COSREC. Also show negative value that indicating significant cloud development, and also Kelvin and equatorial Rossby waves were also observed active in the region. And we believe these are factors triggering the growth of rain cloud in the West Sumatra, particularly around the Mount Merapi area. And the image on the right side of your screen shows a 24 rainfall distribution map, and the purple triangle here indicates the location of Mount Merapi. And from this map, we can see that the heavy to very heavy rainfall occurred in the most area around Mount Merapi. The highest measured rainfall reached around 135 millimeter per day in Tanah Datar Regency, which is one of the areas most affected by the flash flood event. And this is weather radar imagery. Based from this radar imagery, on 11 May at 3 p.m. to 4 a.m. In the following days, in the West Sumatra generally expects moderate to heavy rain condition, and it can be seen from the CMAX product. The value reached around 55 degrees Z, which indicates the heavy rains from 5 to 10 p.m. Local time. And this is from the satellite. Based on observation from Himawari 9 satellite channel 13 on 11 May, significant temperature decreased around minus 60 degrees, and this was not around Agam and Tanah Datar Regency, starting around 1 p.m. Then this is also indicating that rain occurred and convective cloud and began dissipate around 3 p.m. And after that, around 5 p.m., a more significant temperature dropped to more than 70, minus 70 degrees Celsius. And also this is indicating the heavy rain in the area until dissipate around 6:30 in the next day on 12 May. Based on atmospheric dynamic analysis, BMKG already issued an early warning regarding the potential for heavy rain 3 days before disaster, and continuously updating daily. And also, BMKG already issued the no casting early warning for heavy rain, and it updated for every hour. On the day of the incident, BMKG issued about 6 warning from 12 a.m. to 1:30 a.m. In the following days. And next, this is a disaster risk map of Mount Marapi issued by Volcanology and Geological Hazard Mitigation Center (PVMPG). So after the incident, today's after, BMKG HQ sent several personnel to directly assess the location, and I also one of the team to identify the areas still at risk of flash flood. And this part mentioning that the volcanic materials carried by rain caused flash flood around the hills of Mount Marapi, and it was reported that around 300,000 meter cubic meters had been carried away by rain and caused flash flood around the hills of Mount Marapi. And with approximately 1 million cubic meters still remaining at the summit of the Mount Marapi. And this is indeed a significant threat to the area around the hills of Mount Marapi. And if you observe this image, the red the red represents the summit of Mount Marapi, where volcanic ash and cold lava are dispersed, which can be carried by rain. And the yellow area represents the lava flow path, and the dashed red polygon lines here. You can see here the red dash polygon line. It represents the area identified as potentially who have a high potentiality to flash flood carrying volcanic materials. And determination of this area based on the field of observation and also discussion with the relevant institution. And this is video from drone when we make a survey in the West Sumatra. I'll play it a bit, but because the length of the video, I think I will just keep it and fast forward. You can see here the area that affect of flash flood in the West Sumatra. So I'll skip it because I only give 10 minutes for this presentation. And this is the main product I want to show you, because when we go there,
Ridan,
we
your time
yes,
still 2 minutes, please.
okay, okay. After we go there, we coordinate with the local governments, disaster management, rescue team, and other relevant institutions for evacuation and risk reduction process in case of subsequent flash flood. And the result, we develop a special early warning product utilizing satellite and weather radar data. And from this product, we provide weather early warning. If a significant rain cloud cell move toward to Mount Marapi, the bulletin product will issued. And this product include information on which district and sub-district are potentially prone to the flash flood carrying the volcanic materials. And this product also contain recommendation action for the community. And the result actually quite positive, because the local government and units handling evacuation process was significantly aided by our product, by this product. According from the report from the West Sumatra Meteorological Station, several flash flood occurred in the new locations, but the casualties were minimized because uh, community were already evacuated. Based on the early warning, this product what we issued. So this is this is actually an example of best practice in using satellite and weather radar, not only for analysis but also for the preventive measure to reduce risk of the disaster. And we also using this beside the early warning product that I mentioned before. This is one of a product as a forecaster we find very useful in providing forecasts related to area with a high potential for flooding, which is this product is derived from the satellite data. This is a gas map for rainfall accumulation the last 72 hours. And from this product, we can monitor which area have experienced high intensity rainfall over the past 72 hours. So we can assume that the soil is already saturated, and this posing a potential risk of flood or landslide. I think that will be all for my presentation. I'll give it back to you, Richard. Thank you very much.
Okay, thank you very much for the nice presentation, Mr. Idan. And we will move to the last presentation of today from Mr. Bodo from Bureau of Meteorology, Australia. Mr. Bodo will present about composing flooding case study incorporating satellite data with reference of research on Australia Vlab Center of Excellence Regional Focus Group Meeting Archive. So, Mr. Bodo, the time is yours, please.
Right, thanks very much for that, Richard. I might just share the screen. Let's see if I can do that. Okay, just sharing it now. Can everybody see my first slide?
Yes, we can see.
Great. All right. So I was invited by Annie to present during this session, and I thought it would be a really good idea, and Annie agreed, that we would use this opportunity to advertise the flooding case study resources on the Australian VLAB Centre of Excellence Regional Focus Group Archive, because there are lots of resources there. And also the opportunity of advertising some of the products for monitoring flooding that were presented during the regional focus group meetings. But the focus of my presentation is really on neat ways of combining satellite data with other observational NWP data, actually taking some slides out from the selected presentations. So to give you a bit of an idea of the background, these are the presentations that were given during our regional focus group meetings pertaining to flooding case studies, including flooding case studies. And there are case studies from Indonesia, from Australia, from Japan, from Fiji, from the Philippines, from South Korea, from New Zealand, and also from Samoa. Silipa presented that, and I assisted him with that. But most recently, from the Philippines, Ella Marie Serena presented something. So there's a lot of information there. Also, of course, we have their presentations promoting rainfall and flood monitoring products. So William presented during November 2020 about the NOAA Global Flood product. Oki Kim presented GK2A heavy rain detection products in August 2021. Gao Hao from CMA presented the smart Fengyong satellite data and also high-resolution satellite data for meteorological application software. And now Yoshida from JAXA. JAXA gave a great background and some case studies about the JAXA Global Rainfall Watch. And so what I thought I'd do is setting that scene. That's enormous resources that are there. I'm just going to pick some of the slides out to demonstrate to you how you can combine satellite data with other data if you're developing your own case studies. And so here's one example from the regional focus group meeting of March 2021. It's pertaining to a flooding event over Australia, but specifically over southeastern Australia. And here you're combining the OLR, outgoing long wave radiation anomalies, as monitored by satellite, with recorded rainfall at the time or later on, and also looking at the sea surface temperature anomalies, again detected by satellite. So some things here: negative OLR anomalies, enhanced cloud, enhanced rainfall over northern and central Australia. You have warm sea surface temperature anomalies over southeast Australia in the regions shown here. And of course, that contributed to enhanced rainfall over the east coast of New South Wales. You can see how the satellite data is supported by the other data, the precipitation observations. Now, the Silipa Mulitalo presented during the regional focus group meeting of August 2023, the flooding event over Samoa. Now, what's really interesting here is I've combined the satellite imagery, the mimic total precipitable water on the right-hand side with the chart analysis. And you can see this area of high total precipitable water when we go to the beginning of the loop, moving towards Samoa. It's very useful for areas where you don't have much observational data. There's no radar data, for example, over Samoa. Have a look at this area. It's almost like you can anticipate this area of high total precipitable water moving toward Samoa. You also have a trigger. You have this trough over the Samoa. That's of interest. And you have confluent flow ahead of a low near New Zealand. So setting the scene, this is prior to the flooding, but it also helps you to anticipate, and you can use that, the satellite data, together with the analysis. An example from Indonesia as presented by Rian Salman, and I supported him on this. And you can see same thing down the bottom, total precipitable water over the eastern Indonesian region, New Guinea and Australia. But this time we're comparing it to a gradient wind chart at the top. Notice particularly that you, within the area of interest, Ambon Island is what Rian talked about, you do have a surge, a wind surge that's actually helping to, if you like, mobilize that deep total precipitable water into deep convection that then results in the flooding. You can also use other satellite data, such as the ASCAT, to reinforce, and I'll flick backwards and forward a bit, to reinforce your analysis. They're great ways of combining the satellite data with other data to develop a story. Here's an example how you might use the satellite data and to try to quantify, to compare the great ways in which the mimic quantifies precipitable water. You can see that in the top right-hand side. You can see the sounding on the left-hand side from Auckland. This is the case study that Chris Webster presented, and I assisted him with that, and how it compares with NWP data, which is the bottom right-hand side. That's the GFS model as presented in the Earth Null School set. It looks to me like in each case, it's around about 40 millimeters of precipitable water over Auckland during that time. Note too, though, that you do have in a number of the case studies, the soundings, particularly in the lower parts, they turn anti-clockwise, cyclonically rather, with height in the southern hemisphere. That's warm air advection that often enhances precipitation. So keep that in mind when you are developing your case study. Satellite data with soundings, and just try to interpret the soundings too. Oops, sorry. Here, Chris Webster's combined the satellite imagery on the right-hand side with the radar data on the left-hand side. Have a careful look at the intense radar signature in red as it moves down toward the center of the image. And that's your train effect, where you're getting that 40 millimeters of precipitable water mobilizing into the storms, one after the other, after the other, after the other, coming through, resulting in that flooding event where radar reinforces the satellite data. You can use satellite data to verify NWP for flooding events. This is an area over Java. You can see Jakarta there, and you have two models, the EC on the top right-hand side, the Access on the bottom left-hand side. This is a 3-hour precipitation forecast, and down the bottom right-hand side, you can see that verified in the satellite imagery. So then you can compare which model is doing better. You can use that case study to help develop an archive where certain models might perform better at forecasting for certain synoptic setups and so forth. As presented by Dr. Jin Ho Shin, this GK2A RDT product gives, this is more as the event occurs, areas of potentially really intense flooding coming out of rapidly developing convection. Interestingly enough, for the Samoan case study that that Silipa presented, we had an analogy. We actually looked at, have a look at this. This is the island of Samoa, but you're seeing lightning. Look how that lightning is anchored to the topography during the flooding event. And I'll just wait for the movie to go over again. Look at that. That is a sign of intense convection, intense precipitation that is somehow staying just in one place. And as Silipa mentioned during his presentation, topography had a large part to play with that. And so the animation of the imagery really indicates that the lightning is confined to that area in the black ellipse. And according to Silipa, that's due to the interaction of the convergent low-level northeast flow with the terrainance of Savai. And you'll remember that from the earlier slides about the mimic total precipitable water. Finishing off now, just looking at what one might monitor during and after the flooding event. This is a presentation put together by our JAXA colleague, Yoshida-san, and it shows the three-day precipitation, and that's something that Idan mentioned also in the Indonesian context, resulting from Typhoon Lan. And you can actually see the point locations, the precipitation, but also the accumulated precipitation, where you can relate satellite data to what's actually observed on the ground. Another classic use of satellite data to monitor rainfall as it actually moves through the catchment is this one, using the MODIS 721 product. This is for inland Queensland. And you can see in the animation how the waters are actually moving down the catchment. This works very well if you don't have too much cloud cover. My final few slides really deal with the flooding over the Australian region, and just highlighting what I've shown you before. On the right-hand side, you have the MODIS 721, bottom right before the flood, afterwards top right after the flood. you'll see in the true color, the waters are very muddy actually associated with this flooding. But again, what William mentioned, this a particular highlighting the product here, the NOAA Global Flood product, just highlighting the floodwater fraction and extending onwards in saying that those floodwaters are going to move downstream. And this product can also capture these just as well as the Modus 741 product did. And you can see that here. You can use the webcams and drones, just like Idan showed, as well as station data to see, again, the flooding moving downstream. Finally, my final slide, basically the flood waters have to go somewhere. And if they go into the ocean, they can then create this, as you can see with the true color RGB, these brown areas. They're dumping detritus along the coastline. That's a threat for watercrafts. It can deteriorate the beach water, and the drinking water quality can be an issue also. So if you have a desalination plant put up as an emergency due to the flooding emergency, then this helps you to monitor it as well. And I'll leave it at that. Thank you.
Okay, thank you very much, Mr. Bodo, for the nice presentation. So we still have 8 minutes to discussion. We will move to the discussion session. I see a lot of questions in the chat box, so we will start from the first question from Silipa Multitalo to Mr. William and Mr. Leon. On the Real Earth website, how can we access or download the data of flood analysis? Maybe Mr. William and Mr. Leon, you can see the short tutorial for download the data. Thank you. Please.
Yep, just as a quick note, I did put the link to the Amazon Web Service site to download the 1 and the 5-day composites. That's the easiest way to do that. And just to emphasize to everybody who may not have seen my response to that, the NOAA AWS is an egress-free site, so that means it's free to download the data. There are no costs to download it. So I think that's a very important thing to emphasize that. There's also, because the Australian Bureau of Meteorology is still in the process of operationalizing things, personnel issues and the like are always a struggle for, I think, everybody these days. We are at SIMS, we are still producing it. So there are, Rion posted the link to how to access the joint AHI and VIIRS products as well in that link. And again, that's free to access. There's no cost to it to download the data.
Okay, thank you so much for the answer. And we move to the next question from Mr. Ahmad Puta to Mr. Idan. Is the lava flooding in Merapi more due to high rainfall or accumulation of high rainfall from previous day? Then, whether the GSMAP product has been validated with the rain data or surveyed in response, the value of its accuracy. Thank you. Please, the answer.
Okay, which the questions?
The second, Ahmad Putra.
There's a lot of questions here, so I can't see. I don't know. Maybe you can copy the question and send it to me, because I can't find it.
This one.
Last from Merapi. I think for the flooding in Mount Merapi is both to the high rainfall and also the accumulation, because a few days before we also it's already have rainfall a few days before, but on the 11 May is the highest one. So I think it's because of the high rainfall and also the accumulation on the previous day. And then whether the GSP product has been validated with the rain data or the surface rain product, the feel of its accuracy. Thank you. So yeah, so if on my presentation, I actually show the accumulation rainfall for the 12th May. And can I show my screen, Richard?
Yes, please.
Okay, this one. It's a little hard to see it, but yeah. This is for the rainfall accumulation for the last 7 days on the 12th May. And you can see here, this is the location of the Mount Marapi. And as I said before, the total amount of the rainfall on the 11th May is around 135 millimeters per day. And you can see the legend here. The orange one is that shown that the total accumulation on this area is around 150 until 300 millimeters per day, because this is the accumulation of from 3 days. I think I hope that will answer the question, Richard.
Okay, thank you for the answer, Mr. Idan. Maybe we still have one question left before we close because the time is limited. The question is from Diras Tamet Samrat. Question is to William and Ryan. What are the key parameter and indicator to consider when interpreting flood data from the AHI product? And the second is, how can the data from the AHI flood product be best integrated with the existing monitoring and early warning system at BMKG? Mr. William and Mr. Ryan.
Yeah, I can take part of that. So it is a fraction of a pixel that is flooded. So yes, it is an interpretation where a low fraction is flooded. It's typically something that is simply moist, where a higher fraction probably generally is around 50 or 60%. It starts about where you start to consider higher, there's a higher likelihood that there's overland flooding at that point. I think one of the big key considerations, though, is that the AHI product is, of course, at 1 kilometer. So you're gathering a lot of data you're gathering data over a large area. So that's really, I think, the big consideration there. However, it can be I can say how it's being used in the National Weather Service by several of the forecast offices that have used the ABI products for a few years now, prior to becoming operational, is that essentially they take the ABI, the geostationary data as sort of that first look during the day. So as in the morning period, you start to see where the areas of likely flooding are occurring. So you can kind of focus in on those areas. Once the Veers Pass comes in, then you can focus even further down into those areas. So it sort of is a tool to allow you to identify areas of interest, higher areas of interest, and eliminate some of the, I'll say, other areas that may not have as large of impact during the daytime.
Okay, thank you very much for the answer of the question. So everyone, since we have a limited time, we will request to the presenter to answer, and we will upload it to our LMS system for the answer of question. And this is the last. I would like to thank you very much to all of the participants today, especially for the excellent presentation from our presenter. Because of that, we can know and understand to how we utilization the satellite meteorology used for the flood analysis. And once again, thank you very much to all of you, and see you in the next regional focus discussion 2024. And bye-bye, everyone. Thank you so much for attention this meeting.
Okay, bye.
Thank you, everyone. Thank you, Bodo.
Yes. Thank you, Bodo. Thank you, Mr. Rian. Thank you, Mr. Idan. Thank you, Mr.
Thank
William.
you, everyone.
Thank you, An. Thank you, thank you, thank you very much.
Thank you, William. Bye.
Thank you very much.
Goodbye.
Thank you. Bye.
Kak Idam, Marion, makasih banyak ya.
Ya Bu,
Ya,
sama-sama Bu.
sama-sama, Bu.